Hello, I'm glad you could join me today. We're talking about data and statistics. You'll notice here on our main screen, we are beginning our discussion about circle graphs. So, all of these graphs, the bar graphs, the circle graphs today, are all ways to display data. After you collect your data, maybe you've taken surveys. This is a great way to, and probably my favorite way to display data. Is a circle graph. So, a circle graph is just a great way to show part to whole information and part to part relationships. So, we talked about these kinds of relationships back in our proportion unit, and that's going to come back today, and we're going to revisit that. So each portion of a circle is actually its percentage out of 100. So that's going to help us interpret these circle graphs. And the whole sum of the entire circle is going to equal 100%. When you look at a circle graph, I want you to imagine that the circle can be divided into 100 little parts, just like this one here on the screen. So 1% would just be one little sliver out of all of these. So that's what I want you to be thinking of. Now, I actually did make a couple of examples here. In the first example, you can see that I highlighted in pink 25%. So that's about a quarter of the circle. And then I highlighted in yellow 50% of a circle. So you could easily see. Then 75% of a circle looks about like this. And then finally, 10% of the circle is going to look just ever so small, real tiny. All right, so just now you have that image in your mind. Let's start with interpreting another circle graph. So in our first example, I'm looking at this pie chart or this circle graph about favorite sports. This particular problem says that a total of 300 students were surveyed, and so the data was collected, and this is the way we chose to display our data. So when I read this, I'm looking at baseball as being the most favorite sport of these 300 people by 35%. The second favorite is football, and then 20% is volleyball, and 15%, the smallest percent, is tennis. Our question today asks, what is the number of students that prefer tennis as their favorite sport? So what this question is asking us is, out of those 300 people that were surveyed, how many of them actually prefer tennis? So we can do this question, or we can answer this question by writing a proportion. And we're going to use what we know about 15%. 15% is actually written, it can be written as a fraction, 15 out of 100. So that's my first ratio. And then I'm going to set that equal to what I know, what's given to me in the problem. And it tells me that there's 300 total students. And so I'm going to write that in my denominator because proportions and fractions are part to whole. So since I'm looking for the part of our population that is liking tennis the best, I'm going to solve now for x. I can solve a proportion two different ways. I can use scaling, which I bet many of you are already doing, but I can also use cross multiplying and dividing. So if I cross multiply, and I'm going to just do this for all my friends out there who prefer cross multiplying, I'm going to take 100 times x is going to equal 15 times 300. I'm going to simplify that now, and that equals 100x equals 4,500. Now I'm just going to divide by 100, and x equals 45. So out of those 300 students that were surveyed, 45 of those students actually preferred tennis. Let's move on to our next example. And I'm gonna go on to here. Okay, so we have a student council at North Middle School that had an election for a student council president. And the data is here in this circle graph. So let's just take a peek at that for a second. That looks like somebody named Morris had 35% of the votes. Suarez had 40% of the votes. There was 20% that voted for Vox, and then 5% voted for others. So remember that the total has to equal 100. So our question now says, if 280 students voted for Morris, then how many actually were in the election? So they're asking for the total number of students. Okay, so let's break this down. Since we're talking about Morris, and Morris got 35% of the votes, I'm going to write down what I know about 35%. Well, I know that 35% actually can be written as 35 out of 100. Now I'm going to think about what the question's asking me. If 280 students voted for Morris, so we know how many people voted for Morris, and we want to know how many were voting total. So the total amount is what we don't know, and we do know that 280 voted for Morris. So I can set up a proportion just like this. I'm going to use my strategy of cross multiplying and dividing just like I did in the other example, which means I'm going to have 100 times 280 equals 35x. Now I'm going to simplify, so that's 28,000 equals 35x. Now all I have to do is solve for x. I've got something multiplying my variables, so I'm going to undo that by division, by dividing. And when I do that, then I simply get that x equals an even 800. Okay, so that means that 800 total students were a part of that voting process at the election, and 280 of them voted for Morris. All right, so now that we've worked a couple of examples, I want you to show me what you know about circle graphs. Your assignment is IXL BB12. I know you can do it. As always, let's do some math.